Okay, so let's solve for section 2, guys. Okay, so question 21st is following are types of data mentioned in data science. They are structured, unstructured, quantitative, and categorical. So all of them are types of data because structured data, which can be easily stored in tables, like for example, SQL table. Unstructured data, which cannot be easily stored in table, for example, images, audio, video files, blobs, globs, right? Quantitative data, which is numerical data, for example, weight, age, which can be measured, right? And categorical data, which is something like a discrete data or categorization data. Okay. So all of them are types of data. So the correct answer should be A. A, which is J, K, L, and M, right? The following are probability concepts. Independent events, A intersection B is equal to P of A, P of B, correct. Bayes theorem, P of A when B is equal to P of B when A, P of A, P of B, correct. L is expected value, sum of years into variance. Yes, correct. And variance is equal to this is wrong because variance is sigma square. This is a formula of standard deviation because variance formula is standard deviation square. So the correct answer should be JKL. JKL. No. Yeah. Following are data cleaning methods. We drop records, we mean value imputation, nearest neighbor, outlier detection. Correct answer should be JKL because if we are if we encounter missing value, either we can delete that record, either we can impute it using mean of the dataset, either we can impute it using nearest neighbors, or outlier detection not come under missing values imputation, right? So the correct answer should be JKL, which is A. JKNL, right? Now 24th. The following are model philosophy. Occam as a simplest explanation. Yes. Bias variance trade-off. Yes. No free lunch theorem. Yes. Nate Silver thing. Yes. So this all are correct because these all are modeling philosophies in which Occam Razor gave simplest explanation is best explanation. Bias variance trade-off in which if bias is high, variance would be low, and if variance is high, bias would be low, and each of them lead to overfitting and underfitting, right? No free lunch theorem in which no single model is good for all, no single model is good for all situations, right? And fourth is Nate Silver think probabilistically. So Nate Silver gives three rules for probabilistic distribution for modeling, right? So these all are modeling philosophy. The correct answer should be A. Okay, right. J, K, L, N. 25th, following our distance measure, Manhattan, k equal to 1, yes. Euclidean, k equal to 2, yes. Cosine for vectors, yes. In cosine similarity, we just convert the documents into term frequency and inverse document frequency vectors or term frequency vectors, which is we store the word count of important words, and based on that, we obtain a vector data, and based on that, we calculate similarity between two non-zero vectors. So it is also a distance measure and scale divergence for, yes, this is also distance measure in which we calculate the uncertainty gained or uncertainty lost during the when replacing probability distribution A to probability distribution B. So this is also a test. So this is also a distance measure. So the correct answer should be J, K, L, and M. J, K, L, and M. Right? So these are our solution for section 2. In the next video, I will be solving section 3. Thank you guys.